So yeah, today we're going to be talking about implementing serverless at the LEGO group. And just a quick intro to myself before we get into the details. I'm Sarah Hamilton, and I'm an application engineer at the LEGO group. And I'm also an AWS community builder in the serverless space. My journey into serverless started when, well, firstly, I grew up in Wigan, so it's great to be back in Manchester. And then I moved on into a consultancy as a web developer, and then moved on to the LEGO group. One of the key reasons why I decided to work there was because I had seen really great people like Sheen Brizzles, who we saw before, who worked there, so I knew they must be doing some really cool tech, and that's when I decided to apply. I also stole the Twitter handle serverless Sarah, so you know how passionate I am about the topic. So do feel free to follow there, and I write quite a few blog posts on Medium. So the LEGO group has undergone a huge journey. I only joined about a year ago. But right now, the LEGO group isn't fully serverless, but we're very much on a journey, as any big corporation is. And originally, I believe that it wasn't hosted on serverless, and come on Black Friday, things kind of went a bit awry one day. You can ask Sheen a bit more about it if you want to, because he was there. And that was when we realized we really needed to have a very scalable solution right there and then, and serverless is the perfect answer. So the key reason why we use serverless is for the scalability aspect, and also the fact that cost moves along with serverless. So if you're using such an amount, then you're only paying for that amount, and if you're using a low amount, then that's great. So we don't need to worry about the underlying infrastructure too much, essentially. But here you can see we've got lego.com, and I work mainly on the back end of lego.com, and we're very much split up into teams. So for the contents of this talk, I'll talk about the way that LEGO engineering is all split up and the way that we technically achieve that. And then I'm going to go quite deep into some actual examples that we've implemented using just serverless services, all hosted on AWS, of course. So for squad organization, I pulled out this quote from Bezos. So we try to create teams that are no larger than can be fed by 2 pizzas, which some of you may have heard about. Now, our teams are somewhere between 5 and 10 people. I don't think you can feed that many people with 2 pizzas, and I don't think that they're referring to 2 people. So I don't know, so quite small teams is what they're trying to get at. We don't want huge engineering teams. And the reason for this, amongst many reasons, is that we have the Ringelmann effect, which is the tendency for individuals to become increasingly less productive as the group increases. And many of you may have seen that across your organizations, and I see it as well, that the smaller the group size, the more effective the communication is between team members, and it's much harder to hide away in the shadows when you have a smaller team, as some people like to do. So here you can see a subset of a few of our squads at the LEGO group. So I would sit somewhere in the marketing team right now, because I'm an engineer, I'm not high level, I very much sit within my squad. And we have various different teams. But just to bear in mind, we are a big organization. We have about 25 different squads in the engineering team. I've just put a few there on LEGO bricks for you to see. And the point here is that we really need to scale and work efficiently. And so we actually decouple all of these squads into our domains. And we've heard a lot today about domain-driven design and event-driven architectures, but that's exactly how we do it. So in order to decouple our services, we drive it all using events. So all of these different squads don't need to know about each other, and I'll go through how we're all in different code bases. But the main driver of this is the events that are going between the systems. And that's how, when unfortunately some system goes down, such as not the cart system, we won't go with that one, with the product pages, which would also be pretty bad if that went down. I should have picked some more minor ones. It doesn't affect the payment service because they are just decoupled, and it's great for big organizations when bugs inevitably do get pushed into prod. So the first step to decoupling our teams is on a technical level. So once you've defined all of your different domains, such as payments, the payments team is going to get a cloud account assigned to it. So we're not all in the same AWS account. And we do this by using AWS organizations. So that's a piece of functionality by AWS where someone owns the root account. In our case, it would be some specialist IT team that I haven't personally met. But when we set up my squad, we requested a cloud account from the IT team, and it's connected to the root account. So when the IT team gives you your cloud account, it's going to inflict certain policies upon your account that you've requested to make sure that we're all maintaining a certain standard across the organization. For example, we'll have guard duty. And the next part to this is to have a multi-repo approach. So with that cloud account, you're also going to have your code base all sat in your GitHub repository. And this allows for a lot of team autonomy. So we have some teams who are working with C#. Meanwhile, I'm working in Node.js in my team. There's many different benefits to this, including for hiring and also just picking the correct tech for the part of the website that you're working on. And it also allows for better security, so following the principle of least privilege. So I can't push into code that I'm not really a part of. So that works really nicely for us. And hand in hand with that, the team owns the CI/CD pipeline. So this is a great part of having these different repos. So I've kind of had bad times when I've been in a huge monolith and I've been waiting an hour for a CI/CD pipeline to finish, and then some random test fails that has nothing to do with my code. So it's really frustrating in those circumstances. And what's great is when you just have your own tests running on your own code and only what you need to run. So it leads to a lot less frustration, and also the developers get to pick what goes in the pipeline. And finally, on the topic of these squad setups, we can talk about deployments. We have a really nice way of deploying at the LEGO group. I'm sure there's many different ways with pros and cons. But we actually have a nice UI where you can see all of the services on the left-hand side. And you can just click on that and deploy to QA, acceptance, and production at your will. And you can access those parts. So we do have QA engineers who will maybe test on the QA environment. And then once they've given the OK, we can release to acceptance and production. But it really gives us autonomy over being able to deploy when we want to. And just very visual too. So we're going to go a bit deeper now into a few event patterns. So the first one will be streaming events. So the structure of this, I'm going to go through a couple of use cases, then into the solution, and then a code demo. And then we'll repeat for a couple of others. So the first one is customer emails. So this is actually a service that I work on. What we have is that a customer is navigating the website. They've probably consented to cookies and marketing. And then the clickstream data is all sent into the back end, which is the service that I work on. Whoops. And then all that data, we kind of do some logic in the back end and then send off to our third-party marketing provider, which in turn then sends out a customized email to the user. So all that logic is kind of going on in our back end in AWS, and then we leverage third-party providers for other parts of it, such as sending the emails. And before we go into the solution, there's also another use case that we can apply the solution to, which is analytics. So all that clickstream data that we've just discussed feeds into the back end, and then we use an observability tool, such as New Relic, to show things like the popular products and different things that can drive business decisions, essentially. So in order to do this, we have one service to power them all, and this is the service that we have. So I'm going to talk through this a bit in depth. So we have all of the clickstream data that is funneling in from lego.com. So this might be customer clicked on this product or any type of event that you can think of that would happen on the web page. That all gets fed into our backend into something called the data feeder. We have API gateways on the front of our services as a HTTP endpoint. And all of this data funnels into Kinesis Data Firehose. And we choose this, for many of you who may not be aware, Kinesis is an application to be able to stream lots and lots of data, so it's very much useful at high scale. And there's variations of Kinesis, but we use Data Firehose for its ability to batch data and put it into an S3 bucket, so the file storage. Object storage, I'm not sure. But it goes into the S3 bucket. And once it's all batched, an S3 object is created, and that triggers a Lambda function to be ran. And at this point, that Lambda function will go through those events, triage them, and send them off to the relevant services. So in this way, it's all very much event-driven, and the fact that we're using one service to send off the relevant events to the different sources. And it's good to have the triager because you could have 20 services, and one of those might only be interested in one type of event. So the triager kind of does all the work for you. And so just to talk about the events a little bit more, I'm sure many of you have seen events like this. This is a typical event structure where you'll have some metadata and data that you add into it. And you can see here, here's one from lego.com. You've got interesting things like the timestamp, the event type, and maybe the event URL, so what the person was looking at. And all these events, and imagine it's at really high scale. We have so many customers on the website. All of these are coming into Kinesis Data Firehose. And there's a couple of parameters that you can tweak in order to send these data to the S3 bucket in batches. So you can see we've got the buffer size and the buffer interval. And you can see here that the size never reaches 1 megabyte, but the file is created every minute. So it's the buffer interval in this case that is being met every time. But on days like Black Friday, you'll see that they're all 1 megabyte and they're all coming in not less than 60 seconds. And so that's all of the files in S3. So we're just going to quickly demo that so you can see it in code. And just so you're aware, I'll share the GitHub QR code so you can have all these examples to use at any point. So if we take a look at the code first, my framework of choice is the serverless framework, but this can just be applied to anything of your choice, CDK, SAM. But we'll look at the important stuff. So we have the Kinesis Firehose that is set up. You can see it's set up as a delivery stream. We have the S3 configuration in order to send the data. I'm going to enlarge this a little bit in case people can't see. And then we have the buffering hints that I've just described. And then we set up the prefix, which is to say which folder within the bucket we want to send these events to. And also within this, I've set up the triager, so it's just a Lambda function. So we've got the root to the file, and then we have the events. So this is triggered when an object is created in S3 with the prefix ecom events. In the Lambda function, we don't really need to go through all of this. Essentially, it is just sending, based on the type of event that came in, the data off to the various Lambda functions. And I've, for the purposes of the demo, created some Lambda functions to say, OK, if it's type energy, we're going to console log out the energy type. But this is all going to be explained a lot better when I just show you. So if we go into Kinesis Data Firehose, so we've gone into Kinesis, we're in delivery streams, which is the Firehose part, and then we can test with demo data. So AWS provides a really nice kind of dev tool to be able to test this, so I've not had to set up a front end and send a load of data in, and we can start sending demo data. So this is going to send in an event once every maybe 5 seconds. I'm not sure what the thing is, but we're going to have to wait 60 seconds for it to be created in S3 because of the whole buffer interval situation that I've described. So to fill that time, you can see that I do have the S3 bucket prefix ecom events. And if we go into the S3 bucket, I'll come back here to the main part. Then you can see that in management, another interesting thing that I've added to the bucket is a lifecycle rule to delete the data after 2 days. So that's just showing another small piece of functionality whilst I'm waiting for that to be created. And at the Lego group, we do this as well because this isn't our data warehouse. We don't want to retain data for longer than is necessary. So if we go into the prefix ecom events, then naturally it gets added to the bucket in date order. So 2022, it's September, it's the 22nd, and I mean, it says it's the 16th hour, but I think it's like an hour behind in AWS world, but yeah, there it is. So you can see it's been created at 17:38, which is correct. So if we open that file, we can see all of the different data that has come in. Sorry, let's go in here. So you can see we've got a technology event, an energy event, and a healthcare event. So if we come out of this, let's get rid of those, and we go into CloudWatch. In fact, let's go into this one. Then we can go to energy, and we should see that, yes, the Lambda function has been triggered, and only the energy event should have gone to this Lambda. And you can see here we have an array, and obviously only one was sent with energy. But the point here, if I can get back to the slides, and we go back, is that these Lambda functions are acting as the two different services that I described at the beginning. So say analytics was that energy Lambda, and campaigns, it's just simplifying it for a code example, but you can see how we're triaging the events and sending them off, and all of this works at really high scale and on days like Black Friday. And so quickly following on from that, to go back to the examples of the campaign service where the customer wants to receive an email, what you can see here is that this is also all event-driven. So once we've received those events that are only relevant for the campaign service, we use Eventbridge to filter these events further within the service. And I've put it into multiple logic services on there, but it could be things like analyzing the data to figure out whether a user has abandoned their cart. So things like, okay, they've added this, that, and the other, and it's been a few hours. Now we're going to send them an email to say, did you forget about these products? And then once we figure that out, we'll put an event onto Eventbridge and send that data off to the third-party marketing provider, which has a direct integration with Eventbridge to send the customer an email. And finally, the analytics example, we have all the data going into the analytics API, and then feeding that into New Relic. So you can see here, we get interesting items such as the rescue helicopter was popular on that particular day, which drives business decisions. So moving on from streaming events, next we'll talk about Eventbridge, which I'm sure many of you have heard about, especially with event-driven architectures. And the use case example here is our payment service. And it's a really cool service because essentially it's our main revenue point for Lego.com. And in a minute, it has to handle 1,000 orders and 200,000 API requests. So it really does have to scale. And it also needs to remain up because downtime in this service costs us a lot of money. And so the general overview of this service is our payments platform, which is the back end that a lot of our engineers work on. And then we have these business units, which is how customers actually make a payment. So the classic one that we all probably would know is the checkout on the website. But some people like to call up customer services in order to buy an item. Or you can go through other platforms such as Lego Education. So we need to have a single entry point into our back end to make these payments. And then on the other side, we of course use payment service providers such as PayPal, GPay, Apple Pay in order to process these, so we have to integrate with those services. Now, a while ago we had essentially a problem, and I'll describe that now. So we have the payment service, so from the front end, someone makes a payment, you can imagine network request goes off, and the payment request is sent to the payments provider, which may be PayPal or GPay. They send back a synchronous acceptance saying, okay, 200, we've received your request. And then we're waiting for an asynchronous response to say, was the payment actually accepted? So yes, they have received the request, but did it actually go through, or did the card get declined? And so then the payments provider was sending back this asynchronous response, and Lego.com was polling for the status. So if you imagine that Lego.com is polling every 5 seconds. The async response could have returned on the 6th second, but the customer is waiting until the 10th second to know whether it was successful or not. So they're sat on the loading page. And so this isn't ideal, and it's not even just from the customer perspective. We're putting unnecessary load on the payment service, and polling is just generally inefficient for things like this. So as you can imagine, the solution was to push the status update from the payment service to Lego.com. And this all works great. We use Eventbridge to do this because the front end of Lego.com is mainly hosted with AWS, so you can do a direct integration from Eventbridge to Eventbridge, where the payment service has an Eventbridge and the front end service has, I say front end, but the front end will have another service behind it, which has an Eventbridge. So we can just use that async response, put it onto the Eventbridge and send it off to the front end, and the customer is happy. But what about the case where the client, and when I say the client, I mean the customer services team, requires us to push to a HTTP endpoint? So Eventbridge isn't classically HTTP. But in our circumstance, the customer service team has a HTTP endpoint. For whatever reason that is, we have to send it to HTTP. And that becomes a problem. However, of course, Eventbridge now has something called API destinations, where we can push from Eventbridge to HTTP endpoint. And just to describe this, so it's the exact same sort of thing. We have the payments provider providing the async response onto the payments Eventbridge, and then we can set up some target rules, as with other Eventbridge, you can set up the rules. And you've just got to set up the API destination in order to call the client service. And to quickly run through this, the main difference here between normal Eventbridge and API destination is you have this event transformation. So a Eventbridge to Eventbridge, you don't need to transform the event because it's going to readily accept it. But with an API HTTP endpoint, you're going to need to amend it in the way that it needs to be. So here is the event filtering. It's very much like, it's just the standard Eventbridge rule. So you can see on the right that we are filtering based on whether the event has Lego payments and type authorization from this main event on the left. And then when it comes to the transformation, you can see at the bottom might be what the HTTP endpoint wants to accept, and the way that we transform it is through something quite obvious. Well, to me, it's like, so saying detail.data.lego payment ID, so it's just going through the JSON object in order to form the, I can't get the word, but yes, the item that we want to send to the HTTP endpoint. And so hopefully to make it a bit more sense, then we're going to do a quick demo. This one's slightly quicker. So I have this all set up in code as well. And what I've done is I've set up a REST endpoint. This isn't something that I would traditionally do, but for the purpose of the demo, I've set one up with API gateway. So in our serverless YAML, this is a little big. In our serverless YAML, we have an endpoint, which I've just called endpoint, and it has a HTTP post method, so that's our REST endpoint. And in there, I've just put a console log so that we can confirm at the end that we received the event. And so that's our REST endpoint, super simple. In the payment service, I have, if I zoom out slightly, what we have is the Eventbridge that's set up. So we have the internal payments event bus that I've described, and then we have to set up a connection, and I've chosen the API key as the authorization type, but you can choose things like OAuth, but I've just gone for the quick way, and I need to define that here in the connection. And then we set up the API destination, and we add the connection ARN and the invocation endpoint. And the invocation endpoint is that Lambda endpoint, the one that's fronted for Lambda. And then we set up the Eventbridge rule. And so I'm saying we only send events that have Lego payments as the domain type. And then we have various roles, but we won't focus on the I am roles for now. I've just basically allowed a lot of things. So to go into that, if we go to Amazon Eventbridge, we can take a look quickly at the rule that's set up. So we have the custom event bus. And you can see here that we have the rule that we've put all in CloudFormation done in the serverless framework. And if we go to the event bus, we can send the events. Cool. So if I grab that from the README, so here we're demoing us hitting the API gateway with the Eventbridge. So if we call this ComSum and ComSum, and then let's call this ComSum so we can identify it, and we send the event. Now, what we're expecting here is that we've got the console log in our REST endpoint. So if we go to CloudWatch, you can see here that we have received the event at the right time, and we've console logged that out. And this all may just kind of look like, okay, so you just triggered an endpoint via Eventbridge, but the cool thing is the API destination, and generally it's probably not going to be just something, maybe even in AWS, it's going to be some other REST endpoint that you don't have as much control over. And just to show the interesting part, we have the body that we sent here that can be used by the REST endpoint. And just to prove it went through the API destination, you can see that here in the user agent. So it's not just gone direct. So that is API destinations. And the final thing to talk about is orchestration. So orchestration is really important at the Lego group. And we use this especially in our loyalty platform. So this is a platform for VIP members to basically sign up people who really like Lego. And this is all part of one domain. And they use step functions quite a lot. And orchestration is essentially a flow diagram of maybe longer running tasks. So it's very much orchestrating what you want to happen, and it can have a human element as well. So if you need someone to kind of check a tick box, then it's going to wait for that and then enter the flow. And these can last, I know the wait steps on step functions in AWS can last up to a year, and the waits have no additional costs, which is really cool. But that's kind of a very basic diagram of how those work. And our more simple use case would be that a customer is placing an order in the Lego shop. So we do just have a new flagship shop on Leicester Square, so this would be happening there. And customer is kind of placing their order. And at that point, we want to remove their rewards from their account. So we need to remove them before so that they can't be spent in conjunction, say at another store, someone trying to spend rewards at the same time. And then if the order gets abandoned for whatever reason, we want to reimburse the account with the points so that they've not just lost them. So that's essentially the premise. And so here is what happens. Essentially, this data comes through, and we trigger a step function. And what's happening here is a wait step for 2 hours, because that's the time that we've decided to say we can allow it till we assume it's been abandoned. And then if they need to reconcile the data, we then release an event to release the rewards in the session cleanup state. And here, I guess I'm just showing that all of this is still event-driven. We've sent out an event to clean up, and over here, we're then cleaning up the database to make sure that all of the databases are in sync, and that the rewards that the customer then sees are the correct rewards that they should be seeing in their account. So that's a more basic use of AWS step functions. But a more interesting example is when we want to do cross-service orchestration, which is generally something that people may tend to avoid. And what you can see on the left is the step function. And if it makes an API call out to another microservice, as long as it's a synchronous request, it's generally not really an issue. But if it's making a call out for another long-running process, that can become problematic because it's waiting for a response quickly, and that's not something that generally is a normal pattern. But there are ways to do this. So here you can see, and here's where we get a bit more in depth, we have two step functions, one of those being the long-running process that we're describing, that we're calling out to. And the way that we can actually do this with step functions is to add in our Eventbridge, and we can send an event with a task token to the Eventbridge, which triggers the second long-running process. And once that's finished, we can add an event back onto the Eventbridge with the task token. So this is all, we have to add in the Eventbridge and the Lambda, but the task token is inbuilt functionality with the step function. And so that step function is waiting for that particular task token to return. So it's basically a unique ID. And then we'll call a Lambda function to send a command back to step function to say, okay, you can continue running. So that is essentially how it works. And so the final demo of the day, I know that it's getting late, so I'll try and speed this one up. We have our task token example, which again is in the GitHub repo. And firstly, if we take a look at essentially the left-hand side that I was discussing, a order processing step function. And what's happening here is I've set up the step function using serverless step functions, which is a plugin that we can use to define these step functions. But the interesting part here is what I'm saying is send a task token to the Eventbridge, and that is used doing this wait for task token resource and sending this event with the task token. And then once we've received it back, once that other long process has ran and we know it's successful, then we're going to update our DynamoDB table. I've just kind of put in a step there to flesh it out a little bit. And then I've called it the vendor mediator. This is the long-running process that I've described. In here, we have our step function that we're calling, and that's going to update a DynamoDB table again, so a separate one in its own. We're calling it the third party. I've just set it up in DynamoDB. And then send the task token back to the Eventbridge. And then the last thing to look at is in this order processing, we do have the task token response handler, which sends the task command back to the step function to say, okay, this is the task token, carry on with what you were doing. So you do have to add in that Lambda at the moment. Maybe step functions will come out with the functionality not to have to add that in, but we'll see. And you can see here, I've just set up a generic Eventbridge up here, just so that we can send those events. So the final part to demo is these step functions. So we have the order processing step function, and I'm going to start an execution. Let me grab an event from the README. Or maybe I didn't add it. Fun, I thought I did. Here we go. Nice. Ugh. So we're going to start the execution with this event, and let's call it a consum2, and let's assign us all 100 points. So you can see here that, and it's really nice, I'm sure many of you have seen step functions, that it provides a really nice UI. Kind of talking, this is all going to happen really quickly, but update rewards was currently happening while it was blue. And what was happening there is it sent the task token out to the vendor mediator. It waited for it to return in that time when it took a few seconds, and then it updated the table and it finished. And during that time, I'm going to go over to the vendor mediator step function and show you that that did trigger. So at that time, that was triggered with the wait for task token, and it updated the table and sent the task token all the way back to complete the flow. And just to kind of show this as well, the tables did update. I sent consum2, so in the first one, we can see it was submitted, and in the vendor mediator, that also updated with the 100 points. I realize that that's quite a lot, but if you are interested in this example, then do clone the repo and check it out. It's quite simple in code, so do take a look at that. So just to wrap up, I just kind of want to describe that these task tokens can be sent off in many different arms of the step function, so it's not just one thing. You can have it happen in all sorts of places, and we do leverage that. And just to finish off the day, the reason why we're doing all of this is a big one for scalability. So serverless and event-driven architectures really go hand in hand, and because all of the events are handled asynchronously, services can really work at their own rate. So often on big days that we'll have queues of events, and we've just got to work to clear those queues, and it's not a big deal generally, as long as the events can be handled asynchronously and there's not a customer waiting for that response. And scalability on more of a dev perspective, we can plug in new services into the system without affecting the current code so much. So it's really easy to set up new squads and new domain areas to just plug into the current system. Lastly, resilience and fault tolerance. In the case of downtime, as I've said, we just reprocess the messages, and if one service fails, then the other ones are unaffected. And for me, it definitely leads to faster development. So quick to onboard new developers because the skill set required by each individual team is much lower than the whole organization. We don't need to overthink the system because we know that we can only break things within our own system. And it's also just quick to spin up new services and plug them in. So I just want to say thank you, everyone, for joining. A special thanks to Sheen Rizzles, who's really helped me along my journey at LEGO. And also special thanks to my dad, who's come along to see me today, which is really nice. He's on the front row. And yeah, feel free to take the code examples. I really appreciate everyone coming to listen at the end of the day. But yeah, thank you.
Thank you very much. Have we got any questions? Oh, you're closest.
Hi. Do you have any asynchronous aspect to your front end? Like your payment example, for example, are you asynchronous at that point?
So when a person makes a request for a payment, that will, to me, it would be asynchronous in that it's sending off a synchronous request in order to find out what the status is, but it is waiting for a push whilst it's on the loading page from the back end. So in that sense, it is asynchronous, but with these synchronous requests coming from, say, PayPal, those requests are synchronous, but the overall...
The UI aspect, are you using Signala or anything like that to wait for the event? The question is Eventbridge fast enough for customer-facing requests?
Yeah, so I would say that in that case, customers do expect to be waiting for their card to be accepted or declined. That's a classic that we've all been through. But say it's something like, I want to click to go to the next page, that's going to have to be synchronous, of course. If a customer is expected to wait and it works better, then yes. So the payments, yes, fine. But generally, you probably want to keep things a bit more synchronous on the front end, unless it is something like that, waiting for a response from the back end. Thanks.
Do we have a? Oh, okay.
I'm just curious. When you were talking about the Eventbridge, you said something about push notification, and so that got me thinking. Do you use that to push notifications to your subscribers or customers as well, instead of SNS?
So generally, no. I think we have used SNS before for our push notifications to users. I think generally that's a better one for, kind of the multiple subscribers with the SNS, whereas Eventbridge does have the multiple subscribers as well. But no, generally I think we've used SNS to push to customers.
Have one more? Oh, okay.
Thanks very much. assume I'm a new developer starting at Lego, and I'm presented these code bases. How do I know what events I am consuming, creating, and what things are going to be picked up with what? In a distributed, it's a common problem in a distributed model. As a developer, how do I know what to do?
Yeah, so I guess this is a common problem that, yes, we say it's all decoupled, but you do need to know about the events, and then it's like, well, how do you know about the events? So I know that Amazon offers schema registry within Eventbridge, which I think allows you to have kind of documentation of these events, but generally it does rely, and secondly, there are things like cloud events, which allows you to have essentially a schema to basically enforce upon the whole organization so you know what to expect. But really, I think it all comes down to documentation in the end at your organization. I think that's what I would be looking for as a developer when I joined, good documentation.
Okay, got any other questions? Yeah.
So my question's about the weight tokens for the step functions. So
I can't see properly.
yeah,
Oh, I see.
So what are the main cases for using that over, say, just firing another event and waiting for it to finish and fire a Lambda to do the storage? You know, are you tying it to asynchronous calls so that it's guaranteed waiting? Like what's the main use case for those?
So I think generally the use case would be, and just to be clear, I'm not actually in the squad that uses these step functions, so if I got Sheen up here, I'm sure he'd give you a better answer. But what it would be is in this example, what we have is this distributed system where we have the vendor mediator that I described that clears up our third-party database, and we only want that service coupled to that database because we want to not be that classic vendor locked in. So rather than that step function, the first one, amending that database, we want to send off the event to the second step function to amend that table to then come back to say, yes, it happened successfully, and now you can move on with your processes. So that is essentially for the order processing, it's just reaching out to another service to say, rectify that table and then tell me when you're done so I can carry on. So that would be the use case there. And
do you know if they like that sort of it's waiting rather than just having it be sat there listening for the event to fire? I'm asking the question the right way.
So I think the key thing is this, if I'm understanding the question correctly, the task token is kind of a unique ID where it's waiting for that specific ID because, of course, these step functions, there'll be many of them running concurrently for many different customers. So I don't think you could just do it without having excess logic. It's kind of an inbuilt thing.
Right, yeah. And you're getting that out of the box for free with the functionality. Yeah, that makes sense.
Yeah.
Great, thank you.
Thanks.
Alex, can you grab Sarah at the time? Is that all right? If I'm
Yeah.
wrap it up.
Yeah. No, thank you. Feel free to ask questions later.
Are you sticking around?
Yeah.
Fabulous. Right. Awesome.